Okay, this is 8th grade lesson 5.4. Today, our objective, students will use their understanding of properties of similar triangles to solve real-life problems. The standards covered in this lesson are 8G5. The page numbers out of the hardcover book are pages 206 through 211, and out of the practice journal, pages 107 through 110. Today, we're going to be working with similar figures. More specifically, we're going to be working with similar triangles. So what we're going to learn today about triangles also applies to other similar figures. So triangles that have the same shape but are not necessarily the same size are considered similar triangles. They look similar to each other, but they're not exact copies, okay? If they were congruent, then they would be exact copies of each other. To be similar, the figures must have the same angle measures as well as proportional side lengths. So the key thing to understand is if they have similar angle measures, then that means that, or exact angle measures, that means that their side lengths will be proportional. So here it says two triangles have the same angle measures if and only if they are similar. So if we go through and we compare the angle measures, we have a 95-degree angle, a 95-degree angle. We have a 65 and a 65, and we have a 20 and a 20. Because the degree measures are the same, then these would be considered similar. It means that if we knew the side lengths, they would be proportional to one another. So as long as the angle measures are equal to each other on each of the pieces of the triangle, then that means that those triangles are considered similar. So triangles ABC is similar to triangle DEF. This is a way that it may be written. Okay, they're going to use this little squiggly line instead of like an equal to. It just means they're similar to each other. It's kind of like a turned over S. Okay, so we're going to go ahead and practice this concept. So the key thing to remember, if the angle measures are all the same, then they are considered similar. Okay, so here's something that we're going to be practicing. So it says tell whether the triangles are similar and then explain. So we're just going to go ahead and identify whether or not they're similar to each other. So we're going to look at the angle measures. Well, we have a 50-degree angle measure here and a 50 there. So far, those are the same. I need to check to see if when I check 180 minus my 75 minus my 50, if that gives me 55. Okay, and if it does, then they will be considered similar. So when you're working these, you're going to have to solve one of the triangles to make sure that you've got two angle measures that are the same, because then that means the third one is also going to be the same. So 180 minus 75 minus my 50. When I do that, I do get 55 degrees for X. Okay, I don't have to go through and check Y, and here's why I don't have to, because as soon as I had two that were the same, that means the third is the same. So here, because all angle measures were equal, this would be considered, yes, they are similar. Explain why all angles were equal to each other. Okay, even if they take one of the triangles and they turn it, as long as you've got your angle measures, then the same angle measures, then they're going to be considered similar. Okay, so here we have a right angle. So those are the same. I need to check one of the two triangles. This time I'll just go ahead and check this one. Okay, so I know a triangle is 180 degrees. Whoops. 180 degrees. I'm going to subtract off the 90 and then subtract off my 38. And it doesn't matter which triangle I pick. I'm just going to pick one of them and check it. So let's see. 180 minus 90 is 90 minus 38. It gives me 52. Okay, so we have a right angle. I have a 42 and a 52. So these are no longer equal to each other. Why? Because I can tell this one's 42. I can't have a 42 and a 38. Okay, so therefore I've already identified if I want to check, I could go through and solve for X on this side. So I would take 180 minus 90 and then subtract off the 42. That gives me 48 for this one. Okay, we're off by 10 degrees on those two angle measures. They're not the same, therefore this would be a no. Explain why, because our angle measures are not the same. Okay, so it's a yes if we end up with angle measures the same, and it's a no if we have different angle measures. Okay, so I want you to try this one. So you're gonna go ahead and check, you're gonna solve for X and Y, and some of you will be comfortable just solving for one of them. And then you're gonna check to see, do I have the exact same angle measures? Okay, so go ahead, pause your video and work through this one really quickly. Okay, I can already tell that this one's gonna be a no. Just by checking my top triangle when I went through to solve for X, I see that I'm gonna end up with a 72. Here I had 71, there I had a 72. Okay, which means Y is gonna be a little less than, it's gonna be more than 80, it's gonna end up being what, 81 instead. But I could go through and check that. But I can check one of them to identify. So this would be a no, because not all of the angle measures were the same. So let's go ahead and try one more. Okay, so in order for them to be similar, the angle measures have to be the same. So go ahead and try this one. Remember that red corner means 90 degrees. Okay, this was a yes. When I solved one of them, I can tell from solving from one of them, but if I want to reassure myself, I can solve both triangles and then just compare to make sure that all of the angle measures were the same. We have a 90 and 90, a 66, and I solved for Y there, a 66. Here I solved for X, a 24, and that was a 24. So even though they had taken this triangle, shrunk it down, and flipped it, it is considered similar. So that's working with similar figures. So once again, let's review quickly. Similar figures, if they are similar, they will have all angle measures that are the same. The sides may be shorter, but all angle measures will be the same in order for them to be considered similar. Okay, so indirect measure is working with a little bit of geometry. We're going to actually be working with proportions, and we have done something similar to this before. But indirect measure is using similar figures to find a missing measure when it's difficult to find a direct measure. This is sometimes used, like if I wanted to find, for example, here, the height of that tree, I could go through and measure the height of my person. So this is a 5-foot person. And I could measure the person's shadow, which was 4 feet. Now, if you look here, see how I'm actually creating a triangle? Okay, so indirect measure, they're just using the sun to create that shadow. So here I've got my tree that's a certain height, which I don't know what, and I have the shadow that's 30 feet. Okay, these are considered similar triangles. We don't have the angle measures there, but we know in indirect measure that they are creating a similar representation. So we can go through and actually set this up as a set of proportions to find the height of that tree. If we know that the shadow is 30 feet, I'm going to go ahead and just set this up as a proportion. Now, I like to take each scenario and set them up as a fraction themselves. So here I have the tree height, which I don't know, over my shadow. Now, if you had those flipped around, that's fine. But this was my shadow and this was my actual height. Okay, so then when I go to do the person scenario, I need to make sure that I put the shadow on the bottom, which was 4 feet. And the actual height of the person was 5 feet. Okay, so now we're going to solve a proportion. You can go through and say, well, what did they do to 30 to get 4? But that's kind of hard to see. The fastest method, cross multiply, divide. So you're going to multiply where you have those two diagonals. So 30 times 5 is 150. And we're going to divide that by 4. And when I do that, I get 37.5. So this is 37.5 feet tall. Okay, so that's working indirect measure. And we're reverting back to solving using proportions. Okay, so let's go ahead and try another one. Indirect measure, just where you can't actually measure it. So you're using another situation here. We're using the shadow to be able to measure it. Okay, so we have a flagpole and we have a shadow and then a person and a shadow. This time we're just working inches. Okay, so once again, we're creating a similar triangle when I connect the tops to the ends of the shadow. Okay, so I'm going to set it up as a proportion. I like to do each figure as its own fraction. So X over 90. Okay, this was my shadow. This was my actual. Okay, in my second scenario, the little girl was 54 inches over 36 inches. Okay, making sure that you're matching. So here I'm making sure that I have shadows on the same level. Now I'm going to go ahead, cross multiply, divide. So 54 times times 90, and then divide by 36. 54 times 90, divide that by 36. I get 135 inches for this. Now, if I wanted to change that into feet, I could do that. You guys remember how to change inches into feet? Remember our conversion, 135 inches equals blank feet. We practiced this at the beginning of the year. Okay, so my conversion is 12 inches equals 1 foot. And now I can cross multiply, divide. So I end up taking 135 divided by 12. And that gives me 11.25, which is 11 1/4 foot. So that's converting. I know this didn't ask us to convert it, but sometimes they may ask us to do that. So kind of tying in things that we practiced at the beginning of the year with those conversions. Oops. Okay, so here's a word problem. It says on a sunny day, if a 36-inch yardstick casts a 21-inch shadow, how tall is a building whose shadow is 168 feet? So if you're a visual person, you could draw like a really quick picture of this. So I've got my yardstick and the shadow. So the shadow was 21 inches. The yardstick was 36 inches. Okay, then I have a building. So here's my building. Those are windows. I know I'm a beautiful artist. And here it says a shadow of 168 feet. Okay, this one's slightly tricky. Here's why. What do you notice about these? We're working in different units. So we have to, in order to be able to go through and actually use proportions, you have to be working in the same units. So it doesn't matter which one you choose to convert to, if you want to convert into inches or if you want to convert into feet. It's whatever your preference is. I'm going to go ahead and convert into inches, and here's why. I know that if I take that 168 feet and change it into inches, it's going to give me a huge number. So I would rather change each of these into feet. So that means I'm going to take 36 inches equals blank feet. And I know a lot of you can do this without writing it out, but I'm going to go ahead and show you visually for those of you that need it. Okay, my conversion is 12 inches. Remember, we match labels, equals 1 foot. So if I cross multiply, divide, that's going to now change this into 3 feet. Okay, so now I'll go ahead and do the same concept for the 21 inches. I'm just going to substitute in the 21 here. And I will have a decimal here, and that's okay. So 21 times 1 is 21. Divide that by, 21 divided by 12 gives me 1.75. And I'm going to write the 1.75. So I'm going to use those numbers instead. Now I can go through and use, I can go ahead and use my numbers. So I have, this is X, I want to know the height. X over 168 is equal to 3 over 1.75. Matching shadow to shadow, the height to height. So now we'll cross multiply, divide. 3 times 168. And then divide that by 1.75. And that gives me 288, and we were working in units of feet. Okay, if you had gone through and worked this out of inches, we would just take that times 12. It would have been 3,456 inches. Okay, what most likely are you going to measure a building in? You're going to measure it in feet, not in inches. Okay, but because this was a small scale scenario, that's why they measured in inches there. Okay, and some of you might not need the picture. You might be able to just go directly into this type of a format, and that's okay. Make sure that if you choose to do that, that you are identifying the fact that here we were working inches and here was feet. Okay, all right, so let's go ahead and try another one like this. Says you plan to cross a river and you want to know how far it is to the other side. You take measurements on your side of the river and make a drawing scale. Explain why ABC and DEC are similar. And then what is the distance across the distance X across the river. So explain why they are similar to each other. So if we go through and look at this information, well, first of all, if they're similar, that means their sides are proportional. And also they should have the same degree measures. Okay, so here, when we look at this, we're kind of jumping back into something that we did back in section 2. And I'm seeing that I have vertical angles there, which means these are the same. So it doesn't matter what the angle measure is. If it's 58, then that means this one's 58. And I don't know what degree measure that is. I just know that they're equal to each other, which means these are equal to each other, which we already see. And that only leaves us with that third measure if we took 180 minus the 90 minus the 58. Now I'm just throwing 58 in there to give you that visual. So explain why they're similar. They have the same degree measures. Whoops, they have the same degree measures. Okay, so now it says, what is the distance, X, across the river? So now we want to go through and find out this distance right here, the distance across the river. Okay, so we've got a triangle where on the right angle, making up the right angle, it is 60 by 50. And here it's 40 and X. I guess they marked X there, which makes more sense. I was going diagonal across the river. Okay, so now if we go through and we do this, well, I have 60 over 50. So I'm just taking that and writing it up. If you wrote it out as 50 over 60, that's okay. Now what we have to identify is the 40 is matching with which of these two here. That's where we're gonna have to go through and identify. So if I were to take this figure right here and turn it so that my right angle was now on the left side, okay, this would be the bottom, so this would match the 50. So those two are similar to each other. So where I have 50, I'm gonna have to write a 40. Okay, so sometimes they're gonna take that triangle and they're gonna turn it. So similar, when you have similar figures, they're gonna turn them and you're gonna have to match sides. Okay, so now I'm gonna cross multiply, divide. So let's see. 40 times 60 and divide that by 50. It gives me 48. So it's 48 feet across the river. Okay, so that's just taking it up a notch using those indirect measures. Okay, so now I'm gonna go ahead and write a couple up for you to try independently on your own. Okay, so I want you to try this one. If I have a tree, I know, a beautiful tree, and then I have a person here. And this person is, we'll say, 6 feet tall. And their shadow is, we'll say, 8 feet. Okay, I want you to find the height of this tree. So we have the height of the tree, and we'll say that the shadow is, let's say 30 feet. Okay, now you may get a decimal number on this, and that's okay. So go ahead and pause your video, and I want you to solve for X, the height of that tree. Okay, whoops. You should have ended up with 22.5. I'm just double checking myself. Yep, I got 22.5 feet for the height of that tree. Okay, So that's working indirect measure. If you have to draw the picture, you can draw the picture. Sometimes they're going to give you word format. So you might be comfortable just having to draw that picture. Otherwise, yes, I know some of you can go directly into creating your proportions off of that. So to solve for direct measure, once again, those are similar figures when you have direct measure, and you can use proportions to solve for those. Okay, key things to remember out of this lesson: similar figures will always have the same angle measures, and their sides are proportional to each other. Similar figures are not exact copies. They're like a shrunk down or an enlarged version. Good luck with this lesson.